Okay. All right. So today we're looking at composition of functions. Today is the first. And we already kind of looked at the composition of functions. So when we compose two functions together or find the composition of two functions, literally what we're doing is plugging, that's our correct mathematical term, right? Plugging one function or function value into another function. Plugging one function into another function. And the notation for that, how am I going to know I'm asking you to do that? If we have two functions, f of x, so I'm going to say f of x and g of x are functions, right? And this is our function notation. So if f of x and g of x are functions, then the composition of our two functions is f of g of x. I know that looks crazy. This is f of g of x. I'm going to write down here. The way we say that, f of g of x. F of g of x. Alright? Now, go back real quick to our function notation. Our function notation. If I have f of x equals 3x plus 2. F of x equals 3x plus 2. And I ask you to find f of 2. What does that mean? What am I asking you to do? I stuck a 2 in those parentheses. 2 is in the place of what? S, right? And so what do you know to do with that 2? Plug it in, right? So I would take 2, f of 2, I would take the 2 and I would put it in x's spot. Right? And then I can figure out what that is. 3 times 2 is 6, plus 2 gives me 8. Well, the composition of functions works the same exact way, but if you look inside these parentheses right here, what have I replaced x with? A whole other function, right? So instead of just putting a number in place of x, I'm going to stick a whole function in there, but it works the same exact way, all right? So let's look at an example of that. I got to have two functions, right? So we're going to say f of x is, we're going to stick with the same function, 3x plus 2. We'll start off with a fairly easy one. And g of x, let's let that be negative 2x plus 4. There we go. All right. And so I want you to find f of g of x. Find f of g of x. And so what I'm asking you to do is inside f, I want you to plug in g. So I'm going to write that. Inside f, I want to plug in g. What is g? Negative 2x plus 4. And so instead of x, or instead of just a plain number inside of f, I'm going to literally plug negative 2x plus 4 in x's spot. And so now I'm going to have 3 times, instead of 2 in my parentheses, I have negative 2x plus 4 plus 2. Right? It looks like my original f function, but in x's spot, I have all of g. Okay. And I can simplify that. I'm going to distribute my 3. Bam. Bam. So I get negative 6x plus 12 plus 2, which is equal to negative 6x plus 14. And there's our composition of functions, f of g of x. And now I can do that the opposite direction too. I don't just have to do f of g. So let's look at g of f of x. Now it's essentially the same thing, but now I'm going to do it backwards. Right? Now inside of g, I'm plugging f into it. Right? So I want to take g, and what am I plugging into g for x? 3x plus 2. So the function should look exactly like g, except in x's spot, I'm going to have f. Right? So I'm going to have negative 2 parentheses, and I'm going to stick f in there. So 3x plus 2. And then don't forget, finish off your equation, plus 4. And so again, I'm going to simplify, distribute, so I get negative 6x minus 4 plus 4. And that gives me just negative 6x. So g of f of x is negative 6x. And notice I didn't get the same answer. Did not get the same answer. Okay? So the order on the composition of functions matters. Order definitely matters. Okay? All right, so what is the point of this? Why would anybody do this? Yesterday, we talked about inverses of functions. Right? Yesterday, we talked about inverses of functions. So let's take a function real quick. I'm going to stick with my 3x plus 2. And let's find that inverse. Find f inverse of x. All right, and we can make our list. Make our list, check it twice, do it backwards and the opposite, right? If I plug in a value for x, the first thing that happens to it, I'm going to multiply by 3, and then I would add 2. And so I'm going to work backwards. Start at the bottom, work my way up, and do the opposite as I go. And so f inverse of x, I'm going to take x, I'm going to subtract 2, I'm going to divide by 3. We agree there's my inverse? And so if you remember what we said about the inverses yesterday, if I took f of x and I plugged in 0, took f of x and I plugged in 0, plug in 0 to f of x, what do I get? I get 2, right? 3 times 0 is 0, plus 2 gets me 2. And so what does that mean about f inverse now? If I plug 2 into f inverse, what should I get? I should get 0, right? 2 minus 2 is 0. 0 divided by 3 is still 0. Right? And so if I plug some x value into my original function and take whatever I get back out and plug that into my inverse, I should get my original value back out. We agree? Yeah? Okay. What this is the composition. It's the composition. Okay? I'm sticking, think about, I'm sticking f, my thing I got from f, into f inverse. Isn't that what a composition does? Plugs it in. When I plug in my function into my inverse, I get the original value back out. What value was this? An x value or a y value? An x value, right? So if I compose two functions that are inverses, I should get x back out. So let's try that. I want to, here's my f and here's my f inverse. I want to find f of f inverse of x. F of f inverse of x. And so again, notice I'm plugging f inverse into f. So this will be f of x minus 2 over 3. So I'm going to take f, and in x's spot, I'm going to put x minus 2 over 3 plus 2. And let's simplify that. Let's simplify that. So if I multiply 3 times x minus 2 over 3, what happens? The 3's cancel out, right? My 3's cancel out. So I get x minus 2 plus 2, which is equal to what? It's equal to x. Right? It's equal to x. So we can check if two functions are inverses. If two functions are inverses, when I compose them, I'm going to get x back out. And so we can use the composition, of functions we're going to say it in fancy math talk. We're going to use the composition of functions to determine if two functions are inverses. So if the composition of two functions is x, the composition of two functions, I shouldn't have an s right there, if the composition of two functions is x, then what did I just determine? They are the inverse, right? So if the composition of two functions is x, then the two functions are inverses, right? Which we just showed right here. Okay? You good? All right.